This is the Precalculus Fall 2017 ACP review problems. Just before Christmas break, my students took this assessment of course performance, and they fortunately did quite well on some of the ones we've been going over a lot, like inverses of functions, discontinuities of functions, and so forth. But based on the reports I've seen from the actual test results and in communication with some of my students after having taken the test, there were a few types of problems that gave them trouble. And I want to go over an example of each of these. One problem was very much like this one: expand the binomial shown below. And so we have this 2a plus b in parentheses called this quantity 2a plus b to the power of 5. And there were multiple choice answers for this. And what we could do for this, if we want to take the time, we could take this 2a plus b, 2a plus b, and just multiply these together, 4a squared, and then we'd have 2ab, and then we would have 2ab here, and then we'd have b times b, which is b squared. So we'd have 4a squared plus 4ab plus b squared, and then that would be squared into the third power. We could go again and put in 2a and b, and we would get 8a cubed, and over here we'd get 8a squared b, and we get 2ab squared, and then down here in the lower left corner we get 4a squared b, and then we would get 4ab squared, and then we would have b cubed. And then we would say this would be 8a cubed plus, we have 4 plus 8, 12, a squared b, plus 4 plus 2 would be 6, ab squared, plus b cubed. And then we can multiply by 2a plus b again to get to the fourth power, and then one last time for the fifth power. That's a long time, and that's not the way we did it in the class. What we did it is in this particular manner. Now, if you took the time to do it that way, and you probably had plenty of time, you could have done it that way. And it's not that much more. But what you have is a binomial expansion, and you can use a Pascal's triangle, like the first row is to the 1, then you'll have 1, 1 is the second row, and then you'll have 1, 2, 1. You just add together, we'd have 1, 3, 3, 1, and 1, 4, 6, 4, 1, and then we'd have 1, 5, 10, 10, 5, 1. And this would be the fifth row. This would be to the first power, second, third, fourth, fifth. And that's pretty easy to do, just writing out the triangle like this. In the calculator, if you go here, you go to Menu, Probability, Combinations, and we could choose our, let's see, that's going to be, what is it, 5, comma, and then we go get our bracket, 0, comma 1, comma 2, comma 3, comma 4, comma 5, and we would get the same thing, 1, 5, 10, 10, 5, 1. The same pattern we got using the Pascal's triangle. So we would have 1, and we'd have this 2a to the 5th power and b to the 0 power plus 5, and we'd have, I don't know why I put those lines there. I don't know why I did that. So we'd have this 2a, which would be 1. That would be the 5th power. B to the 0 plus 5. We would have this 2a to the 4th power, b to the 1st power. We would have plus 2a to the, well, I forgot the 10, didn't I? Plus 10. We'd have this 2a to the 3rd power. We'd have b squared plus 10. We would have 2a to the squared power, b to the 3rd, and we would have plus 5. We'd have 2a to the 1st power, b to the 4th power, plus 1, 2a to the 0 power, and b to the 5th power. So, and if we just took 2 to the 5th power, 2 to the 5th power is 32. Our answer to this would be 32. A to the 5th power plus, we would have 2 to the 4th power, and 2 to the 4th power is 16. 16 times 5 is 80. So we'd have 80 a to the 4th power b plus, we would have the third term here, 2 to the 3rd power, which is going to be 8 times 10. We'll have 80 a to the 3rd power b squared. Then we would have plus this term here, 2 squared is 4 times 10 is, we have 40 a squared b to the 3rd power plus, and we'd have 2 to the 1st power is 1 times 5 is 10, so we have plus 10 a b to the 4th power plus 1 down here b to the 5th power. So this would be our answer. I had less than 25% get this one right in the regular test. Now the pre-AP people had a slightly different looking problem, and they did great on this, but the non-pre-AP people really struggled on this one. Should have been easy, especially with the time you had for that one. Next, find the possible rational roots of the function shown below. And I don't know exactly what it looked like, but what you have for the rational roots theorem says the rational roots are equal to plus or minus factors of last term divided by plus or minus factors of first term. And so what that would be, the last term is 18, so you have, the answer is going to be plus or minus factors of 18 divided by plus or minus factors of 2. And so I'm just going to write this over to the left. the factors of 18, which is our first term, are going to be, I'll just start with, let's see, 1, 2, 3 is a factor, 4 is not, 5 is not, 6 is, and 9 is, and finally 18. So you have plus or minus these things here, and then we have the first term would be factors of 2, so we'll have 1 and 2. So you can just take these one at a time. So we'll have plus or minus 1 over 1, so we'll just say plus or minus 1, okay, and then we'll take 1 over 2, so plus or minus 1/2. So those are possibilities. Then 2 over 1 is going to be plus or minus 2. And then 2 over 2 is already 1, so we already did that. Then we're going to have plus or minus 3 over 1, so that's going to be plus or minus 3. And then we have 3 over 2, so we have plus or minus 3 over 2. Okay, and then, let's see, 6. Well, we have 6 over 1, so that's going to be plus or minus 6. And I'm just going to come down here, and then 6 divided by 2 is 3, so we already have 3. So now we're going to go to the 9. We have plus or minus 9 over 1, which is plus or minus 9. And the 9 over 2, we have plus or minus 9/2. And now we have to 18. Well, 18 divided by 1 is 18, so we have plus or minus 18. And then we have 18 over 2, which is 9, which we already have. So this will be our list of possible rational roots using the rational roots theorem. Okay, next, in a geometric sequence, the value of the first term is 1 and the common ratio is 3. What is the sixth partial sum? Well, you have to know some things here. You have to know what a geometric sequence is. You have to know what a common ratio is. We're given the first term is 1. What a partial sum is, it's the terms of a sequence added up together. And so the sixth partial sum is going to be the first term, and the first term is already given. It's equal to 1. And the second is going to be 1 times our common ratio, which is 3, which is going to be equal to 3. Our third is going to be this third term here, or the second term, times 3. So 3 times 3 equals 9. And our fourth is going to be equal to 9 times 3 equals 27. And then our fifth is equal to 27 times 3, which equals 81. Our sixth is going to be equal to 81 times 3, which equals, I think that's 243. And if we add all these up together, okay, I'm just going to put this 1 over here just to get it in line. So we have 1 plus 3 plus 9. That's going to be 13, plus 7 is 20. 20 plus 1 is 21. 21 plus 3 is 24. So 4 is there, and it was 24, so we have 2 in this column. So we have 2 plus 2, which is 4, plus 8 is 12. 12 plus 4 is 16. So we put 16 here, the 6 down here. We leave this 1 over here. And 1 plus 2 is 3. So our answer for this is going to be 364. And there are different ways to do this. You can do this as a summation. You can say, okay, I'm just going to use my calculator, and we're going to start out with 1 times 3 to the power of k, and we're going to start out with k equals 0 up to 5. Because 0, if we plug in 0, we're going to get 3 to the 0 power, which is 1 times that. If we have 1, we get that. Yeah, that's going to work out. So if we go to our calculator, we can go to right next to the 9 here, pick this key. We'll have k equals 0 all the way up to 5. And over here we'll have 1 times, we're going to have 3 to the power of k, and I hope we get 364. Yeah, we do. So 364 is our correct answer for this one. So those are just a few of the problems or types of problems we had on our test. I hope this is helpful to you. Good luck. We always learn from our mistakes. The biggest room in the world is the room for improvement. Thanks for viewing.